Okay, hi, welcome. Hey, as always, a cheering Norwegian crowd. You know, it's lunch is over, so welcome to another boring protocol talk. Excellent. It's kind of a tradition now that every year I'm coming to this event and present a spec, you know, like basically what's new in IETF land, so to speak. Yeah? And not a spec that is in the making. There are specs in the making, but one that is actually published that companies are implementing. We implemented it for sure. And that I think is very useful. This one is actually one of my favorite specs for a long time because it is simple to implement but gives us much more security, so the ratio is pretty good. So last year I talked about DPoP. Does anyone know what DPoP is or use it? Yeah, it's a proof of possession mechanism, okay? Which is all about securing the back channel and API calls. And today I'm going to talk about PAR, which is securing the front channel. So how many of you are working with OAuth client libraries? Yeah, I pretty much figured that. How many of you are actually implementing OAuth authorization servers? Yeah, bad advice. That's good. So the talk is for both of you. Yeah, so it's both about giving you an idea what PAR is and showing you how it works and how it looks like, and also giving you some implementation advice as well. Okay, so my name is Dominick. I've been implementing token servers for the last 20 years, for the better half of my career, at least. And it turns out the last one I built turned into a commercial product. It's called Duende Identity Server. It's a .NET-based OpenID Connect and OAuth implementation. And that's what we're basically doing these days. We are maintaining that product. And as it happens, last week we released the latest version, which has PAR support implemented. So that's kind of like a nice coincidence. You can contact me on this email address, and if you want to have the slide deck, that's already uploaded here on speakerdeck.com. Cool. So we have to revisit the OAuth code flow. I'm not going to bore you with all the details. In fact, Philippe, my co-speaker, once opened maybe the most specialized OAuth conference in the world, the OAuth Security Workshop, with the words, if you don't know how code flow works, you won't have much fun in the next coming days. So I will not go over every single detail. I will not bore you with a sequence diagram and all of that, but we have to revisit it to appreciate what PAR is actually doing. Yeah? So the OAuth code flow, or the authorization code grant, as they call it in the RFC, is the 95% of the time, if you're doing OAuth, you're going to use this thing. Yeah? It's built for interactive applications, meaning you're sitting in front of a browser, you're sitting in front of a mobile application, whatever. Anytime a human being is interacting with the authorization server, or I should say a client on behalf of a human being is interacting with the authorization server, the so-called OAuth code flow is being used. Yeah? And the specific property of that is that it has two steps. One is called the front channel, and that is always browser-based, right? So that is for bringing the human being into the OAuth flow. That's what's showing maybe the login page and the consent page and whatever other UI you have. And the good thing is it's in a browser, right? So you can just give it a URL, the browser will follow it. The bad thing is it's in a browser, and the browser will just take the URL and just follow it. Yeah? And the human is involved in important security decisions very often. Yeah? Now, when the front channel is done, so all of the UI things are done, then the authorization will return what we call an authorization code, and think of that as a ticket, and then the client will turn around, open a back channel communication, hand in that ticket, authenticate with the server, and then retrieve the actual artifacts, which is access tokens, refresh tokens, identity tokens, right? So that's how that works. Very interesting detail here is you see the client only gets authenticated on the second step. On the first step, the client is completely anonymous, right? which is a very important thing to keep in mind, what PAR is actually trying to improve here. Yeah? So the front channel. Basically, there's an endpoint in OAuth called the Authorize endpoint, right? And basically what the client application is doing, it constructs a URL and puts all kinds of parameters on that URL, like what is my client ID? Where should the authorization code be sent back to? How should it be sent back to? Is it a form post or a redirect, a query string? What data or resources does the client want to have access to? In this case, it's an API, for example. And there are all kinds of other parameters that you're adding, like maybe you want to indicate to the authorization server in which language to show the login UI, for example, or think of arbitrary other stuff. Actually, the whole protocol is designed that you can add arbitrary other stuff here, right? That the protocol specifically says you can add additional parameters that the authorization server might understand. So actually, let me show you that in action. So here's an OAuth or OpenID Connect client, right? So I'm opening the network trace, I'm clicking the login button, so to speak, yeah? And what we'll see is, here's the so-called authorize request, right? So here are all of the parameters I just mentioned, the client ID and the redirect URI and the scopes and the response mode and everything else, right? So this endpoint is specified by OAuth, and it must understand all of these parameters. And then after validating those parameters, actually only then the UI is shown. So the login page is only shown after the authorized request has been validated, right? And all of these parameters make sense. And only after that, we're going to see a UI, or you might see an error message, yeah, saying like invalid request or whatever it is, yeah. Now, I can tell you that between this GET request and this redirect here to the login page, there are multiple thousand lines of code in identity server validating the parameters, right? So what do you think from a security point of view? Is it clever that from the outside you can send all of these parameters? It gives an attacker a lot of stuff to play with, right? So what happens if I change the client ID parameter? What happens if I change the scope? What happens if I change the redirect URI? What happens if I change this parameter or that parameter? How will the authorization server react if I'm trying all kinds of permutations of parameters? You know that there's actually a special technique in pen testing called parameter fuzzing, right? Where they take those parameters and they shuffle them around and add some random stuff and just see how will the software react. And I can tell you, validating this URL here is not easy. Yeah. Also, keep in mind that at this point of view, by definition and by design, the request is anonymous, right? All the authorization server gets is a GET request, an HTTP GET request with stuff on it. Yeah? We don't know at this point if the client is really called MVC code or client 1 or whatever, right? All we have to say is, okay, we take that data and now, okay, he says he's client 1. Now we're going to pull the configuration data from client 1. Does all of the things that he wants is allowed by policy for client 1? Is the redirect URI allowed for client 1? Does client 1 have access to API 1 or not, right? All of that must happen, so to speak, even before we authenticated the client. And if we could authenticate the client in the very first step, that validation would be much simpler, right? But we kind of have to trust that this is, well, the client, right? So that's kind of like, the problem space here, that this URL is attackable, brittle, in a sense, yeah? And if you're reading, which I actually would highly recommend reading, the so-called OAuth security best practices document from the IETF, they go long ways explaining how the validation of that authorized URL is important, right? And you probably all heard, and that's probably the most common attack here, attacks against manipulating the redirect URI, right? So wouldn't it be great if an attacker could just manipulate that parameter and suddenly the authorization code gets sent to domain attacker and not to domain user, so to speak, right? If they could get that authorization code, which is the crown jewel here, right? I mean, that's the thing you don't want to lose, yeah? That would be great, and there have been historically dozens, hundreds of attacks where they basically attacked bugs in the authorization server implementation, right? Especially when people try to be clever. Things like introducing wildcards into redirect URIs, like star.mydomain.com, which includes all the subdomains, right? And then there are subdomain takeover attacks, and suddenly this thing ends up somewhere else, or mydomain.com/star, which means every URL on my domain, again, hundreds of attacks, successful attacks have been carried out by manipulating redirect URIs and exploiting bugs in the implementation of the authorization server. Yeah? Or maybe, maybe the authorization server has some misconfiguration. So does anyone remember this thing with Pokemon Go on the iPhone, where it turned out that they, by accident, they granted every single scope that they had to offer to this client ID. We are all developers, right? Like, yeah, let's just give him all access to make sure it works, and then we'll dial it back before production, right? Well, yeah, that didn't happen. So they figured out that basically by using the Pokemon assigned client ID, they could just append arbitrary scopes and get access to arbitrary stuff on the authorization server, because that was actually not a bug. It was just a misconfiguration of the authorization server, okay? So, that's basically the problem space here, that historically this authorized request has been hard to secure. And you see, basically, besides all of the open redirection problems, there are other things like CSRF attacks, for example, which you must protect against. Then there are things like Pixie. Who has heard of Pixie? That's good, yeah, because we are at a security conference. If you would ask the same question at a normal developer conference, where they are all also using OAuth, there would be less hands, right? It's an advanced thing, if you like. The state parameter has to be used to bind the user agent to the, all kinds of things have been added to the authorized request to make it more resilient against manipulation or attacks, okay? So that's kind of the thing. So, and in addition, to summarize that, there is no integrity on the authorized request, right? Just as I said, yeah, you can arbitrarily change the data. The authorization server wouldn't know. Yeah, they wouldn't know that this combination of parameters is coming from a legitimate client, or you just handcrafted a URL, okay? There is no confidentiality on these requests either, right? I mean, even if it's going through TLS, it goes through browser extensions, it goes through reverse proxies, it goes through log files, URL parameters are in log files, all of that. And, there are standards around there like open banking, where you maybe pass like account numbers or other things on the authorized request so that they can populate the consent screen. Again, no solution to that problem. Also, I said the spec explicitly allows adding more parameters as you go, right? I mean, you could add your own custom parameters. You could, like, have you ever seen a scope string which becomes really large because you have so many scopes in your organization, right? They get bigger and bigger and bigger and bigger. There are many more things you can add to the authorized request, like RAR, the authorization detail, where you add like a JSON object that represents your scope, for example, whatever. So, they get big. That is a problem as well. For some browsers don't support these URLs. Some cloud platforms have firewalls that cut off. For example, Azure did that. I'm not sure if they still do it, but they only allow 2 kilobytes in the URL, for example, which you can quickly exceed with this mechanism. And the last thing, I guess, which is also pretty nice from an attacker point of view, is since this is a self-contained URL, right? You can just write your own authorized URL and put it into an email and send it to you and say, click here to win an Xbox. Right? And I said, okay, Xbox, can't be wrong. Let's click this thing, but what you're actually clicking on is an authorize request. Right? And then this kicks off to the authorization server, and maybe on that authorize request, there's a manipulated redirect URI, and now you logged into, and that actually happened, right? Office 365 or Microsoft, Azure AD by the time, and then this triggered basically transmission of codes to a different place, or triggered consent, yeah, things like that. So all kinds of, like click what do you ever call them? Click attacks, phishing attacks, is easily possible because it's just a GET request, right? You're sending it to the server, job done. So that's the problem. Now, what would be solutions to that? Well, first of all, probably the best would be if there would be no parameters at all, right? If there would be no parameters, there is no opportunity for manipulating them. It's kind of hard because we need to tell the authorization about what to do, right? What to do with that user agent. So the next best thing would be, can we make them tamper-proof? So in a way that only the legitimate client can generate the URL, and if I would manipulate it after the fact, it would fail a signature check, for example, something like this, right? Or what would also help is if we could authenticate the client right at the authorized endpoint before even the whole thing starts, right? If we could do that, then only legitimate clients in our system can actually generate authorized URLs, and you cannot handcraft them anymore because you are not the right client, right? These would be potential solutions to the problem. Now, what do we have? As you can see, there is a spec which is not new. It's actually quite fascinating sometimes to look at these timelines. So by the way, who is actually reading RFCs? Yeah, I totally recommend that. They're not as bad as it sounds. They even now use non-Courier fonts now. They have HTML versions of the spec, so it's a little bit, gentler to the eye. And they're good reads. I mean, not all of them, but apparently I think they're fascinating because I'm doing talks about them. Yeah. But basically, the idea was, like when the whole OAuth OpenID Connect thing started, yeah, every problem in the world could somehow be solved with a JWT, right? You just throw a JWT at it, yeah, and put a signature on it, problem solved. Yeah? And that's exactly what this spec is doing. It says, like, why don't we just wrap this whole thing into a JWT, put a signature on it, and then if somebody would manipulate the URL, it would fail. Okay? And as you can see, that's not a novel idea. So if you look at the timeline, the work for that started in 2010. Yeah? By a guy called Nat Sakamura. And you see basically up till 2014, it was his own little spec document. And then it was adopted, as they call it, by the IETF in 2014. And then it just took 8 more years to become a standard. Okay? Why is that? We'll see in a second. Then it was finally published in August 21. So how does it work? Well, basically, as I said, you take your authorize request, and instead of putting all the parameters in clear text onto the URL, you just remove them and replace them by a single parameter called request. Okay? And what is a request? I mean, everybody knows there are 3 dots in the string. It must be a JWT, right? And it is a JWT. Basically, if we would unpack this blob of data, it would look like this. So basically, all of the parameters that used to be on the URL are now inside the JWT. There's a signature attached to it, and that makes them tamper-proof. It also gives you client authentication, right? Because only the legitimate client with the right key could have created a signature. So if the validation succeeds, it comes from a legitimate client. Yeah? Do you see a problem with this approach? Does this make the URL shorter? Yeah? Okay. Yeah. Also, but by the way, if you have any questions, feel free to stop me at any point in time. It's a short spec. It's going to be a short talk. we have time to discuss. Or maybe not, we'll see. Anyways, that was the approach, okay? So it's a spec, it's out there. We have implemented it, not many other people have implemented it. Why? Well, because there were some issues with it, right? It's increased complexity at the client, so now the client library needs to create those shots. There is some key management obviously involved, right? I mean, you need to sign something, that means you need to have a key, yeah, and that might imply that in addition to the client secret you're already using, you now need to deploy some cryptographic keys. You know, maybe that was a good opportunity to get rid of your shared secret, client secrets, yeah? But most people don't. So that there is a key involved, yeah? Even after, what, 3 years after the release, I don't know any client library that is used mainstream that implemented it, yeah? So, and if you don't have a client library, what's the point, yeah? And of course, the URLs get bigger. There are also performance concerns, I guess, if it's a low-powered client device and need to do crypto operations, and you know, there are all kinds of concerns with this. While this is used in banking, you know, like in systems, basically in closed systems, right, where you control the server and the client libraries, maybe they have implemented this because it is a requirement in certain places for what is called FAPI, the Financial Grade API standard, for example, where they say like clear text authorized requests are not allowed. Yeah? So the spec discusses all of these shortcomings, and also they come up in the end with another way of transmitting that shot to the authorization server, which is called pass by reference. Okay, so the idea is, with that, is instead of putting the shot onto the authorized request itself, the client creates the shot, stores it somewhere, and then gives the server the URL to that stored shot. So instead of putting the whole thing on the authorized request, it basically says, okay, and by the way, my request object, as they call it, is here, just grab it from here. Now, do you see a problem with that? Who has heard of server-side request forgery? Right? So basically telling a server to go to a URL of your choice to do something is probably not the best idea. Yeah? Yeah. So when you look at the security considerations section of the RFC, they specifically talk about this. So first of all, you know, that there are the general risks associated with URIs. Okay, so yeah, URIs are hard to pass. There are some things I, you know, didn't even think about, but yeah, they're totally right. Yeah, it's a nice denial of service attack vector. So, for example, you could handcraft this authorize request and put a request URI on it, and now that points to a server that you control, which opens the socket and then just does nothing. It just leaves the socket open. Right? And now you hammer the server with these requests, and every time they consume a socket which can't get closed until the server is running out of sockets. Okay? So there are some issues here. Or just very slow to respond endpoints. Yeah? Oh, that's another one, yeah? Maybe your request URI points to an authorized object with a request URI, and now you bring the server into a recursive lookup situation. Okay? So not out of socket exception, but out of, you know, Stack Overflow, so to speak, yeah? What else? Unexpected locations, implement a timeout. There are all kinds of URI rewrite concerns here. So basically what is all required was that upfront the authorization server had basically an allowed list of locations where to read that request object from. And that must be configured upfront, of course. Yeah? And what was the other one? Latency, definitely. I'm trying to think. There was another concern here. Pardon? Firewall. Oh yeah, firewalls. Yeah, it's all zero trust these days. We don't need firewalls anymore. Yeah, and network connectivity, just in general, I guess, is another interesting problem here. So at the end of the spec, of the JWT spec, they actually hinted at a possible solution for the problem, and that is, you know what, don't let the client just store that JWT in arbitrary locations. Maybe the authorization server itself should offer a JWT storage mechanism, right? So that basically first the client pushes that JWT to the authorization server, yeah, and then you get back an ID, whatever, right? And then when you do the authorize request, it only will basically go to that internal storage and not do the arbitrary network access, right? So it's basically a pushed authorization request. Look at that. Yeah, so as you can see, the PAR work started basically around the time when they were when all of these concerns with the JWT-secured authorization request became apparent, and as you can see, it only took less than 2 years, right? Because people realized, maybe that's a much simpler solution than putting JSON web tokens on URLs and figuring out firewalls and whitelists and all kinds of other things, okay? So that's this spec. And as I said, it's been done in a much shorter time. It's a much shorter spec as well. It's very easy to read. I think 20 pages or something with the typical, preamble and whatever. So it's a good read. And the idea is super simple. Actually, it's strikingly simple. Namely, that the authorization server provides a special endpoint called, in this case, the PAR endpoint, yeah, where it accepts posts of authorization parameters. Okay? So basically a client, in this case, a client called client, opens a connection before even doing the browser business, right? Before even starting the browser or doing the redirect, it opens a backchannel communication, it takes all the parameters it is about to send, yeah, and it pushes that on this backchannel connection. So what's the great thing about this? We can authenticate the client before the authorize request, right? To be able to push those parameters to the server, the client needs to authenticate. So we know who the client is. Our validation logic becomes much simpler because we now have an authenticated client to check all of this against, right? And once we are happy with that, what we are returning back to the client application is basically a request URI. So that's basically just a URN. The spec recommends using URN, :par, GUID. Okay? And that represents your pushed parameters, and they will be valid for 90 seconds. Okay? So what does that give us? A lot of things. A, we control the location from where we can pull authorized parameters at runtime. It will be always exclusively our own pushed authorized request store and no other network location. Okay? It controls reuse semantics in the sense of that we are in control of the quality of the request URI identifier, which is a GUID in this case. We can implement things like one-time only use of that GUID, for example. Yeah? We can ensure the entropy, make sure this is a good parameter, and we ensure the lifetime for how long the authorization server actually keeps hold of that. And after 90 seconds, this thing is invalid, we can clean up our database, and it's gone. Okay? Let me show you a demo of that. So, you see, when you're implementing PAR, there will be a new entry in your discovery document, which is called the pushed authorization request endpoint. Okay? So that basically tells the client when they do discovery where on the server is the endpoint where I can push my authorization parameters. And then they have another thing that they want to see per spec. It's called require pushed authorization requests, and that is for situations where every client in your authorization server would switch to pushed authorization requests only, which is an unrealistic scenario because, I mean, you're dealing probably with older clients and migration and so on. So for a pretty good time, you will have old-style clients with the authorize parameters and newer style clients that support pushed authorization parameters. Yeah? Anyways, let's run this. Par, MVC, par. Doing the same thing. So we can't see the back channel communication, obviously, in the browser tools, right? But if I go to the log files of our server, you see here, basically someone is invoking the PAR endpoint. And now the beauty of that is we can now authenticate the client, right? As I just said, before they can even use the PAR endpoint, we can authenticate the client using any client authentication mechanism. Might be shared secret, might be, you know, a public-private key pair, you know, you name it. Basically, any authentication method that is already supported at the authorization server can be used also to authenticate clients at the PAR endpoint. Yeah? And then, you know, all of the usual stuff happens. The login page has been shown, as we can see here. And if we go to the browser tools, you see, basically now that's our new authorize request. It has a client ID on it and a request URI parameter, which is basically the value that came back from the PAR request. Okay? Now, internally, you know, basically we substitute the pushed ones with the ones that normally come in. From our point of view, this looks like a normal authorize request, just that now the parameters never went over the browser front channel, so to speak. Okay? Yes. First of all, the client ID is the only, who was asking that? Oh yeah. So the question was, is there a reason we need a client ID? Yes. First of all, the client ID is the only mandatory parameter in OAuth. They didn't want to break the OAuth spec by removing the client ID parameter. Okay? But for a more practical reason, so the PAR spec does not only allow you to push the authorized parameters as key value pairs in a form post, there could be a JSON Web Token. There could be an encrypted JSON Web Token. Now, how would you decrypt the JSON Web Token if you don't know to which client it belongs? Right? So that's the practical reason why you need that client association to maybe do a more advanced processing. Yeah? And again, in banking, for example, where they push highly sensitive stuff that, you know, for non-repudiation purposes, they need signatures, maybe they need encryption for confidentiality reasons. And that's why the client ID is there, but also to not break RFC 6749. Yeah? Cool. Any other questions about this?
How does it work with Pixie? Add the code verifier?
Yeah, it's actually here, code challenge. Right? Basically, you know, it is just your normal authorized parameters, just not on the front channel, but on the back channel. Besides that, it's exactly the same thing. Okay. And then, yeah, ultimately, as you've just seen, what the client is doing is going to the authorize request, sending client ID, sending the request URI. They have 90 seconds to complete this, which is, you know, or it's configurable, I guess. And then after usage, this thing will be gone, right? And if no one's using it, it'll expire after 90 seconds, which is the default value, and it'll be gone as well. Now, what's the great thing about this is now, can you use this for phishing attacks? Well, can the attacker create a pushed authorized request without knowing the credentials of the client? No, right? So you can't just package up everything now in this URL and give it to you and you click it. They can't create this. Yeah, which is great. Yeah. And there will be probably a certain amount of time where authorization servers will support both. Yeah, so starting with our latest version, we support both styles for every client. Yeah, but at some point, once your client libraries have caught up here, you can just set, in our case, just set the require push authorization to true, and then that's the only way how the authorization server will accept authorized requests from that client. Okay? So that's pretty cool. I like it. There's an interesting catch here, which when I first read it, I thought like, nah, that sounds like a huge headache. So so we've been trained as OAuth professionals that in OAuth you must only ever use a pre-registered redirect URI for the client, right? No wildcards, no regular expressions, magic going on, right? The client must pre-register the redirect URI, and only that pre-registered redirect URI can be used. Yeah? Interesting, and that came from, again, practical reasons. If you're using pushed authorizations, you basically authenticated the client before the authorized request. And in that case, and only in that case, you can argue, why can't the client choose the redirect URI themselves? Let that sink in for a minute. Yeah, so basically they're making the argument, since the client is already authenticated, why don't we let them choose the redirect URI dynamically? And while I always thought like, yeah, I don't know why I would ever do that, it turns out there are some practical use cases in banking again, where you have to do that. Also, turns out we have a customer that said they're running this big signature portal, yeah? And by authenticating the client before the authorized request, they make their self-service story much simpler, because now they don't have to basically go somewhere, and whenever they want to change their redirect URI, they don't have to go somewhere and register a new one, or maybe even talk to some help desk thing or whatever. Once they are a registered client in the system, they can control some of their configuration dynamically. And that's not a concern because the client is authenticated. Of course, this only works for confidential clients, right? So no JavaScript. I mean, who does JavaScript these days? You shouldn't, yeah? Not for security, at least. But for the classic confidential client scenario where the client lives on the server, why not allow this? Yeah. I still always crumble when I see that, because I've been, but it's in the document, so it must be official. Well, it is official. Okay, so that's an implementer's note for those who are writing their own authorization servers. As it turns out, completely changes your internal validation pipeline. That's what it did to us, at least. Yeah. Another things, there are some other security considerations here. Of course, these redirect URIs, they should be hard to guess. The request URIs should be hard to guess. So yeah, use GUIDs, not incrementing numbers, something like that. Yeah. There is, of course, an open redirection concern, but with PAR, what you do is you don't follow HTTP URLs anymore on the request URI. You just wouldn't do that, right? You would require it to be like a URN : PAR : a number, and then you would always go to your own store. Don't even have some logic that would allow that. Yeah. Replay attacks, of course, that's where the timeout comes in and the one-time usage comes in. It's actually, as it turns out, pretty hard to implement one-time usage on the internet, right? So the original specification in OAuth, for example, said the authorization code should be one-time usage as well. Yeah, so basically when you're receiving an authorization code from the server, it should only be allowed to be used one single time. Yeah. It turns out on highly scalable clouds and sharded databases and whatever, it's pretty hard to implement this. And there was actually when you're doing this certification for OpenID Connect, right in the beginning there was a test case where they tested if you are allowing the authorization code to be used twice, and because the spec said so, and most companies failed because it was hard. You know, like imagine like requests coming in, it's like almost like a race condition style request coming in. Yeah, the browser is resending something, or maybe you are driving into a tunnel. And you couldn't, you know, like you got the authorization code, you tried to send it, it didn't work, you send it again, or whatever, right? There are all kinds of situations where the real world networking systems get in the way, but you can do your best by giving it short timeouts and deleting them after usage, yeah? And the last thing, client policy change, well, you know, it basically talks about the fact that you should have some sort of stringent client configuration system that says like this client is allowed to use PAR, this client must use PAR, and that's the only way how we interact with them. And historically many authorization servers didn't do that, but in our case we always had this, you know, this C# based, whatever you want to call it, configuration thing, where you can tie down exactly like which flow is the client allowed to use, what are the redirect URIs, do you allow an access token, which scopes are allowed, and we require pushed authorization requests. Or we require signed pushed authorization requests would be another interesting spin on that, yeah? Okay, cool. So, as I said, it's actually a simple spec, which is good, right? So it's not like a huge spec that takes ages to implement. It's pretty simple. You implement the endpoint, you are accepting the parameters, you're storing them temporarily, you hand out an ID, and you accept the ID at the front channel. That's pretty much it. And that's why I like it so much, because the ratio, as I said in the beginning, the ratio between complexity to implement and gain in security is pretty good, right? Whereas there are other specs where it's immensely hard to implement it to get a little bit more security, and then because it's so hard to implement, you're adding bugs into the implementation that the security goes down again, right? So that's kind of the thing. My personal opinion is, now that we have that spec, there is no point anymore in using old school authorized requests. Why would we? I mean, the pushed ones are much better, yeah? Now the problem is, of course, client libraries need to catch up here, right? So the spec is relatively new, and apparently, as you've seen in my little ASP.NET example, it worked, right? So when I go to web, MVC, PAR, Microsoft, and kudos to Microsoft, actually. Even if that OpenID Connect handler was written, I don't know, 6 years ago, it already had the extensibility points that we needed to 6 years later implement PAR, which is quite nice, right? It's not as clean as it could be, but you basically see the thing we're doing here is we are hooking the events on the OpenID Connect handler, and there's an event called redirect to identity provider, right? And at that point, we have all the parameters. We can now open the back-channel communication. We can substitute the original parameters with the thing coming back from the endpoint, and off we go. Yeah? It's a bit more complicated than that because, yeah. Anyways, we spoke to Microsoft. Unfortunately, it was very bad timing because it was 4 weeks before they released .NET 8, so they didn't add this little feature for us. But in .NET 9, Microsoft will add another event handler that will make implementing PAR basically like a couple of lines of code. That's it. Okay? So that's good enough, I guess. That code is on our repo, github.com/doendesoftware. You'll find the samples, and it's all there. Okay, cool. So that's it. Any questions? Yes. Oh, thank you. Thank you. Thank you. Who was first? Yeah. Yeah. Mm-hmm. So the question is, was this a good idea to open up redirect URI validation? Yeah, as I said, I was very surprised to read this. As I said, I always crumble a little bit in my stomach when I read it again. I can see that from a threat model point of view, it's okay. But I can also see that developers are now starting to, cut some corners again, right? The whole wildcard thing was never really necessary because the state parameter in OAuth gives you a chance to do the redirect on the client side where we should be, right? But you're running a big cloud, you have your application running on en.myapp and de.myapp, and why do I have to create 26 client registrations? Just put a star in there and make my AS smart enough, right? Yeah, I agree with you, and the spec doesn't say you must implement it, it's a may. Which is a very important distinction here. We implemented it because we have customers asking for it, which have legitimate use cases, but we only allow that, as I said, if the request came in via a pushed authorized request in the first place. I wouldn't take it personally if you wouldn't do it like that. Next question. Yes. Because you're troubleshooting by, so the question is, will this make troubleshooting harder? It depends on what you observe, right? If you only observe the browser traffic, yes, of course, it's not visible anymore. We are, in our case, we are pretty good, I think, in logging output to see what's going on. It gives you a chance to also send back error codes. But yeah, I mean, you're right. If all you have as a troubleshooting tool is the network tools in the browser, it will be not as obvious anymore. Yeah. Philip first, yeah, and then you.
Would there be any value in having VAR for, let's say, mobile clients? Their own execution and the browser as
So the question is, is there a benefit for mobile clients? So first of all, the PAR is specified for all the OAuth flows. So you can use it in mobile clients. I don't think it hurts to use it in a mobile client. I think the mobile client is a bit better off as usual because they are not running completely in the browser. They're only using a very special browser, a very secured browser, typically like the operating system provided authentication browser to send those parameters. But I mean, the same concerns apply, right? I mean, they end up in reverse proxy log files, they end up in server log files, and by adding a PAR on top, you eliminate this. And you're also getting rid of the possibility that somebody can construct URLs for phishing attacks, which is also quite nice, I think. Yeah. And the last one was, oh yeah, and just to alleviate your concern, PAR only allows to change the URI, the return URI, if the PAR request was authenticated. So a mobile client would not authenticate at the PAR endpoint because they are public clients by definition, so that URI manipulation thing wouldn't be allowed for them. So yeah, I think the gain is lower than in browsers, but still present. Yep, we do, but then we don't allow the dynamic redirect URI change. Yes.
Now that you've implemented support for this standard, did you see any shortcomings with it, or did you want to change anything?
No. So the question is, do I see shortcomings or problems with it? No, I don't. As I said, it is pretty trivial to implement for a good gain in your overall security. And I think it's the best of both worlds. So, they started with just pushing key value pairs, and then the banking people came in, so they, but we need non-repudiation, so they added allowing to push JSON Web Tokens from the back end. And I think that's pretty much how it should be. And if you look at the work that is post-OAuth, the GNAP protocol, that's how they do it from day one, basically. Any more questions? Okay, then thanks for staying with me for the boring protocol talk. Thank you.